Thank you so much for joining this session. My name is Muazma Zahid. I am a senior engineering manager at Microsoft, and I will be talking to you today about cloud data engineering and what it entails. A little bit about myself. I am currently, as I said, a senior engineering manager in Microsoft Azure. I was born and raised in Pakistan and currently located in Seattle for over 10 years. I have been in the tech industry for around 13 years now. I'm a mother of three beautiful girls. Super passionate about data, cloud computing, and AI, and I'm involved in several diversity and inclusion efforts at several levels. I actually run a nonprofit called Pakistani Women in Computing. Please check us out if you don't know about us. I'm also a community lead for Need the Be org here in Seattle and run several events for them, and also a cloud track lead for Women Who Code. So I'm super passionate about talking to you all today on the topic of cloud data engineering and what it entails and how can you start your career in cloud. And I'll share several resources with you. This is my LinkedIn and Twitter. Feel free to follow me or connect with me or send out questions to me in the chat window. I can see the chat window here as well. And afterwards, also feel free to reach out and connect during this conference, and otherwise as well, happy to answer any questions. So let's dig into the topic, which is what is cloud data engineering? So before I dig into the technical aspects of that, I wanted to share some quotes with you so you understand why I'm talking about data and why I'm talking about data engineering and data science and data analytics, right? 2 years ago, economists proclaimed that data is the new oil. So that means that it is the most valuable resource that is available on Earth today. So as a data engineer, as a data scientist, as a data analyst or business analyst, it is our role to actually find it, extract it, refine it, and actually distill its value. So it's very important that we kind of combine the data and its value. And I'm going to be talking about that in the next 20 minutes with all of you today. I love this quote by the VP of DreamWorks, Kate. She says that data is the new oil, AI is the new electricity, and IoT is the new nervous system. So as you can understand, these are the key things for any system to work or any net of things to work. So in the today's art or industry, if you have a startup or a business or any kind of business or thing that you want to run, you need to understand how these technologies can actually help you make your system better or make your company better. And one important quote that I always like to share is the amount of data that we have today. So today, as part of this conference, we are generating a bunch of data on the tweets, on the chat, on the Hopin platform. There's this estimate that by 2025, in next 5 years, there will be 150 zettabytes of data, which is 150 trillion gigabytes of data, which is 4 times of the data that there was there like 4 years ago or 3 years ago. So the data is increasing at an increasingly large speed. So why am I talking about cloud and why I'm talking about data engineering, data science in cloud? It's because the speeds and feeds at which this is increasing, it's enormous. So we need more engineers, we need more folks, people who have understanding of data and who can actually convert this data into meaningful value for the business. So this is another just from 2018 jobs landscape. So what are the types of jobs that would be generated in this? I know with COVID, these numbers might have changed a bit, but if you look at the top 10 emerging roles, you will see at least 3 or 4 are related to data. And that kind of impacts like what disciplines to use. So if you're a student and you're looking at right now what disciplines to take, I would highly encourage to look into big data, data science, AI, ML, and related fields, and look at the career according to that. And I'll share several resources also for you to actually go learn about what you can do and upskill yourself in this area. So what is cloud computing? Let's just debug, or let's just dig into it, right? You hear a lot of these technologies like DevOps and serverless and fast and container as a service. So it's all super confusing. So I want to just oversimplify it for all of you here today so that you can actually look into what it entails for you and how can you start your data journey in cloud. So to me, cloud computing is simply put a set of servers connected in a network which somebody else owns, right? You don't have to worry about the infrastructure in that sense. It's a set of things that they're connected over the internet. You can connect to it. You can put your code in this set of servers, in this databases, in this networking, and run at a huge scale. So for example, if I am a business owner and I have a website today, I don't need to worry about bringing in the hardware to actually plug in. If my user base today is 100 users and tomorrow it's going to be 100,000 users, I basically work with a cloud provider like Amazon AWS or Microsoft Azure or Google Cloud or Alibaba or Oracle. There are several cloud provider companies out there that can host your application, that can host the website, that can host the code that goes into it. So to me, it is the scale which cloud computing brings. As long as you have the dollars or the money to actually pay for it, it's the infrastructure that's already there. So let's just further dig into what are the different options, how you can actually start looking into that. So there are on a high level these four types of different cloud services, and there are a few others that we will talk in the next slide as well. But if you look at the very high level, these are the four types of different services that you can today start building your cloud applications on or databases on. So first one is infrastructure as a service, where the cloud provider, in this case the AWS or Azure or Google, is actually providing you an infrastructure and you're bringing everything else to it. They are not actually maintaining the software that runs on that infrastructure. They're just providing you a set of machines to run your stuff on it. The second level is platform as a service, which is basically they are responsible. The cloud provider is responsible for the whole platform. So they are actually responsible for any upgrades, any security issues, anything that happens on that platform. And there are several examples of PaaS services right now. For example, you can use a database like MongoDB or a Hadoop-based cluster in Azure, like HT Insight and others, that are platforms that are already supported. So you basically bring in only the functionality on top of that platform, but everything for that platform and the software is actually maintained by the cloud provider. The third one is a software as a service. We all are very much used to it, like Google, Gmail, all of these services are maintained as a software by someone, and we just basically go and use that software. The fourth one, which is actually gaining a lot of interest these days, is fairly new, is serverless or functions as a service, where your code is actually divided into small set of small things that you can do, and each function or each step in that process is a code base in itself, and you do not worry about where it actually runs. So all you worry about is providing the code and how it connects to each other, and the infrastructure and platform and how they actually connect is provided by the cloud provider. And I'll give you more examples of this, what it means and how you can start your journey in any of these, and how you actually know about the difference when you're building a pipeline in cloud. So this is a visual about the same thing that we talked about. So on an on-premise environment, when you have your own data center, actually you are responsible for all of these things, including your functions, application, runtime, containers, hardware, and operating system. As you move towards cloud, and as I talked about in infrastructure, containers, platform, and function as a service, you actually lose the control because you give more of that to the cloud provider of the AWS and Azure and Google and Alibabas of the world. But what you actually gain is the scale. So you as an employer of your company doesn't have to hire DBAs, for example, to manage your databases, because the DBA work is taken care by the platform as a service, in this case like Azure, Google, or Amazon will provide that function. But what you bring is the code and the functionality or the application that you want to run. And with a few clicks of button, if you want to scale up or scale down, depending on how the volume is to your website, you can easily do that. One of the most common architecture of how you actually start a building data pipeline in cloud is a Lambda architecture. It's this diagram is oversimplified, and I am oversimplifying it here, but happy to answer questions at the end or afterwards as well. So in any organization, you have lots of data, right? You have an Excel sheet, you have tons of Excel sheets, you might have a database, you might have a CRM system, you have a lot of those things that can bring data in. So once you have the data and you know how to connect to that data, you have two essential paths to actually take an action on the data. For example, if you are a credit card system, the path that you have to take for fraud is definitely the hot path. So you want to know within few seconds if somebody is trying to do fraud on your credit card. So the hot path is basically near real time, some kind of speed layer on top of that. So there are many softwares or applications out there that you can use today, like streaming systems, like Kafka's, like Spark Streaming. So you would use some kind of messaging to put this data on, and then you would use some kind of processing on top of this data to know if this is actually a fraud or not, and then some kind of alerting on top of it, right? So you will build that pipeline on the top here, and that's called the speed layer. So if you have Alexa or Google Home at your home, you would know what I'm talking about. When you are talking and asking a question, Alexa, what's the weather today? You don't want to wait like 10 minutes for Alexa to get back to you, right? You want it to be real time. So all of that pipeline that is built on the behind is using this hot path. Then the second path, which is the cold path, is a long-term plan where you actually have to store this data and you have to look year over year or month over year kind of analysis. Or it could be once or twice in a day that you want to process the data into some meaningful information downstream. So most of the aggregated kind of data streams are actually in the second path, which is the cold path. That is a traditional warehousing where you have some kind of big relational database system like Amazon's Redshift or Azure SQL Data Warehouse, or a third party like Snowflake in there where you can actually put the data in an aggregated form. And on top of that, you have some kind of reporting, either Tableau or Power BI or something that is running. And finally, of course, you have some kind of client where you run these queries from. So it could be SQL based, or it could be some others. So that's a typical architecture where I see a lot of customers using. They could choose to have both paths for the data. They could choose to have just one path. And depending on what your problem you're trying to solve from a business use case, you will choose one of the paths and the services that are related to that to actually implement that. In terms of a cloud data pipeline, a little bit going into the details of this architecture and kind of debugging or going into the details of what that looks like. Of course, it starts with a set of data sources. Those data sources could vary in the volume, it could vary on the types, it could vary on where they are geographically located, how do you actually connect to them. That is the first of very basic thing you need to understand, because not every data source is going to be the same. Some would provide you data once a week, some would provide near real time, and some would be like IoT sensors, which are generating data all the time. So understanding of your data source is really important. Then where do you actually store it? Is it going to the real-time path, or is it going to be a cold storage path, which is more cheaper, right? The path on the top here, the data storage path, is the expensive path, is the less expensive path. The real-time path is much more expensive because you have to take action. You need to put it in some kind of queue. You need to write some kind of code on top of it. So that path, it is definitely more expensive. It requires more compute. So understanding of the difference is really important. Then what do you do with this data? What type of learning or machine learning or AI models you want to run on it? Is it near real time? Is it going to be once in like 6 months? Once in like 6 hours? It varies totally depending on your use case. And finally, putting in some kind of reporting and taking an action on it. So that's what a typical pipeline looks like. And I'll give you some use cases or examples in a second. And as you can see at the bottom, there's an orchestration layer, some kind of scheduling, some kind of running it on a regular basis that most of these organizations actually have. So just to simplify all the things that I talked about in the last two steps, last two slides, is there are important steps that you have to take with the data, and there are some important concepts that you need to understand. So the steps could be: how do you extract the data? How do you ingest the data? Where do you store the data? How do you prep and train the models? How do you actually visualize? So those are all the important steps that the data takes in a typical pipeline in cloud world. It all is also true for the on-premise world. It's not just for the cloud world. The important concepts that are different in cloud are the concepts about compute, storage, network, and security. Those are the four basic pillars of when you actually build something in cloud. And it's really important to understand the difference of what a scale up versus scale down is versus a scale out versus scale in is, because you can add more nodes to a server that is different than if you just change the type of the server that you're using. For example, if you have a 4-core machine, you can actually use, you can do a 8 core machine or 32 core one machine that can do 3 or 4 times the same work that you're doing, or you can add more nodes to your cluster. So the important concepts are very different in the cloud world, and you can learn through that, and I'll share resources where you can go and learn these things. Some important applications or examples of these cloud data pipelines that you must have seen in your day-to-day life are a connected car. For example, from my mobile app, today I can actually unlock my car, I can heat my car, I can actually look at where it is right now. If you have one of these the newer cars, right, you can actually do that. So how does that done? So how does that happen? So basically all of that is a near real time kind of data pipeline that are connected to a cloud, and they are synced to your server where your mobile app is connected to, and this all happens in near real time. This is the hard part that I was talking about. A lot of you must be doing a lot of online shopping because we are all home these days. In online shopping, there's a lot of recommendation and systems built. So all of those machine learning models are actually built on top of what is your past history, what do you click on, what your preferences are, and all of that is built on the data that they have collected about you over the years. There's a very good example here that I've already given about Alexa and Google Home, which all happens in near real time, right? When you ask Alexa, what's the weather? Alexa already knows that I'm talking about the weather here in Seattle versus if it tells me a weather about somewhere in Abu Dhabi, that would not be relevant to me, right? So all of these anomaly detection, like fraud detection, anything is happening on suspicious activity on any of these accounts, all of this is happening near real time. So all of these are actually, if you go into detail of that, are actually data pipelines that somebody has built and stored either on their on-premise world or for the larger scale in the cloud world. And then traditional BI reporting, if you are in any of the organizations, you must be knowing it already. You have sales reports, you have month-over-month kind of analysis. Those are all the typical examples of data pipelines that are built, and they could be built on the set of infrastructure that I described earlier. Important considerations when you're building these pipelines, very important for all of you to understand, is the DevOps. How do you automate these pipelines? How do you secure them? How do you connect to them? One very important thing most of us forget is the availability and the disaster recovery. What if data center in which I am storing all the data is down, or I'm not able to connect to it? So it's very important to have these concepts in place. Very, very, very important in cloud world is the cost, because with few clicks of a button, you can cost your company way more than what you were thinking about. So please be very cognizant about that. And of course, how do you monitor that? And some of the top tools, technologies, and skills that are relevant to it is SQL, Python, R, any of the ETL tools, Hadoop-based ecosystem, NoSQL like Cosmos DB, MongoDB, all of them. And then streaming pipelines like Apache Kafka and Apache Spark are the top two that are going, if you have those skills, if you want to build those skills that are really in the market right now in data governance. Last couple of slides, some important courses that you can go today and take. Right now, because of COVID and everything, a lot of these courses are free that you can take, and I'll be sharing the link for the slides that you can actually find that. Some certifications that you can also do in these. If you want to become a cloud data engineer, you can take the AWS, some Microsoft or Google certifications. You can add it to your LinkedIn, and that will make you more desirable for some of these companies. And some of the conferences that are related to this also related to, like AWS reInvent, Microsoft Build, Ignite, Google Next, and some of the other specific to data ones that I also speak more oftenly, that would be very useful for you. Some other ways that you can learn, you can go to kaggle.com, you can compete in some of the competitions over there, learn a lot more over there. There are some open data sets in Google where you can download any of the data sets and do a lot of analysis by yourself. There's this another website, Analytics Vidya, that's really useful. So if you want to learn any of those skills, feel free to go over there, try out some data sources, try some analytics on top of that, try to solve a problem. For example, a friend of mine just did a survey and collected data on mental health, and she actually built UI, which is telling a story about a particular region, what people are feeling, if they're anxious, what they should do, and all of that is based on real data that she has gathered over the time. Last but not least, I want to just leave this with you all. To me, the last thing is what a data scientist or data engineer or a cloud data engineer is doing. We all have data. How do you connect the data? How do you bring out the insight out of the data? How do you convert that insight into a wisdom? How do you actually make an impact in your company using the data? And that's the key of a data analyst, a data engineer, a data scientist in any of their organization. With that, I am done. Thank you so much for your time. More than happy to answer any question. I think we have 1 more minute here. Happy to answer any questions. If you have any, please leave them in the chat. If not, you have my LinkedIn and Twitter. Feel free to reach out to me there, and happy to connect there and talk more about what you are doing, how you're using data pipelines, and hope you enjoy the rest of the conference.